Humanity has always searched for beauty in the unknown, and sometimes we found it. A planet surrounded by rings so vast they seem impossible. A world that looks calm from a distance, but hides motion, structure, and complexity within. For centuries, it was just a distant shape in the sky. But when we finally saw it clearly, it became something else entirely. This is Saturn. Saturn is instantly recognizable. Its rings are unlike anything else in the solar system. They extend hundreds of thousands of kilometers outward, yet are only tens of meters thick in many regions. From a distance, they appear solid, but they are not. The rings are composed of countless particles. Rock. Thus, some are as small as grains of sand. Others are as large as mountains. Each particle orbits Saturn independently. Together, they create the illusion of a continuous structure. But the rings are dynamic. They shift. They interact. They respond to gravity. Saturn is not just a planet. It is a system in motion. Saturn's rings are not uniform. They are divided into distinct sections. A ring, B ring, C ring, with gaps between them. The most famous is the Cassini division, a large gap within the ring system. These gaps are not empty. They are regions where gravitational interactions shape particle distribution. Saturn's moons play a key role. Their gravity influences ring particles, creating waves, gaps, and patterns. Some moons act as shepherd moons. They maintain ring edges, preventing particles from drifting away. The result is a system that appears stable, but is constantly evolving. Wave patterns move through the rings. Density changes over time. The rings are not static structures. They are governed by orbital mechanics. Like Jupiter, Saturn is a gas giant. It is composed mostly of hydrogen and helium. There is no solid surface. Descending into Saturn leads into deeper layers of gas. Pressure increases. Temperature rises. At deeper levels, hydrogen transitions into liquid and metallic states. Saturn is less dense than Jupiter. In fact, its average density is lower than water. If a body of water large enough existed, Saturn would float. This is a theoretical comparison, but it highlights Saturn's composition. Despite its size, it is not solid. It is a massive layered atmosphere. Its visible surface is just the top of cloud layers. Our understanding of Saturn changed dramatically with spacecraft exploration. The mission Cassini provided the most detailed observations. Cassini orbited Saturn for over a decade. It studied the rings, atmosphere, and moons. It revealed fine structures within the rings. It measured particle composition. It observed seasonal changes in Saturn's atmosphere. One of its most dramatic moments came at the end of the mission. Cassini performed a controlled descent into Saturn's atmosphere. It transmitted data until the final moments. This was not just exploration. It was direct measurement to the very end. Saturn is no longer just a distant object. It is a system we have touched, measured, understood, in part. Saturn's atmosphere appears calm from a distance. Soft colors, smooth transitions between bands. But beneath that appearance lies extreme motion. Wind speeds on Saturn can exceed 1,800 kilometers per hour, faster than any winds found on Earth. These winds are driven by internal heat. Saturn emits more energy than it receives from the Sun. This energy rises from deep within the planet, powering atmospheric motion. Like Jupiter, Saturn's atmosphere is organized into bands. But the contrast between bands is less pronounced. Storm systems are more subtle, more fluid, yet no less powerful. The atmosphere is constantly moving. Jet streams circle the planet, driving long-term patterns. Unlike Earth, where land disrupts airflow, Saturn's winds move without interruption. They circle the entire planet, endlessly. At Saturn's north pole, something unusual appears. A geometric shape, a hexagon, 6 sides, sharp edges, stable over decades. First observed by the Voyager missions and later studied in detail by Cassini, this structure defies expectations. It is not a solid structure. It is a jet stream, a standing wave in the atmosphere. Its shape is maintained by differences in wind speed across latitudes. Laboratory experiments on Earth have reproduced similar patterns in rotating fluids. But seeing it on a planetary scale is something else entirely. The hexagon is large enough to fit Earth inside it, and it rotates with the planet. Inside the hexagon lies a powerful polar vortex, a storm system at the center. This is not a coincidence. It is a stable atmospheric configuration, a balance of forces, still not fully understood. Saturn is not silent. Like Jupiter, it produces lightning. But Saturn's lightning is even more powerful. Storm systems deep within the atmosphere generate massive electrical discharges. These storms are often hidden beneath upper cloud layers. They are detected through radio emissions and occasional visible flashes. The atmosphere of Saturn extends deep below the visible clouds, thousands of kilometers. Pressure increases gradually. Temperature rises. At deeper levels, the composition changes. Hydrogen transitions from gas to liquid, then potentially into metallic hydrogen. These layers are not directly visible, but they are inferred through measurement, gravitational data, magnetic field observations, wave propagation. Saturn is not just what we see, it is what we measure beneath the clouds. Saturn's atmosphere changes over time. Storms form, they grow, they fade. Every few decades, Saturn experiences massive storm events. These storms can encircle the entire planet. They disrupt normal atmospheric patterns. They inject energy into the system. These events are rare, but they are powerful. Saturn is not static. It evolves, driven by internal heat and atmospheric dynamics. Understanding Saturn helps scientists understand gas giants as a class, not just in our solar system, but beyond it. Many exoplanets discovered are gas giants, some even more extreme. Saturn provides a reference, a nearby example, a system we can study in detail. Saturn is not just a planet surrounded by rings, it is a system. A complex network of moons, particles, and gravitational interactions. More than 140 moons have been identified orbiting Saturn. Some are small and irregular. Others are large enough to be considered worlds in their own right. Among them, two stand out: Titan, Enceladus. They are not simply satellites. They are environments, dynamic systems with processes that resemble those found on Earth, and in some cases, extend beyond them. Studying Saturn's moons is not just about Saturn. It is about understanding where life could exist beyond Earth. Titan is the largest moon of Saturn. It is larger than the planet Mercury. And unlike any other moon in the solar system, it has a thick atmosphere. This atmosphere is composed mostly of nitrogen, with methane playing a key role. On Titan, methane behaves like water on Earth. It forms clouds. It falls as rain. It collects in rivers and lakes. Surface images from the Cassini mission revealed liquid methane seas, shorelines, channels, a complete weather system. But Titan is extremely cold. Surface temperatures are around -180 degrees Celsius. Water is frozen solid. Methane takes its place in the cycle. Titan is not Earth-like, but it is Earth analog. It shows that complex environmental systems can exist under very different conditions. Future missions aim to explore Titan in more detail, including the Dragonfly mission, which will send a rotorcraft to its surface. Titan is a laboratory, a different version of planetary chemistry. Enceladus is much smaller than Titan, but it may be even more important. Beneath its icy surface lies a global ocean. Evidence for this comes from plumes, jets of water vapor and ice particles, erupting from its polar region. These plumes were directly sampled by the Cassini spacecraft. Analysis revealed water, organic molecules, salt. These are key ingredients for life. The heat required to maintain this ocean likely comes from tidal forces. Saturn's gravity flexes the moon. This generates internal heat, keeping water in liquid form. Enceladus is one of the most promising locations for life beyond Earth. Not because life has been found, but because the conditions exist. Water, energy, chemistry, and importantly, access. The ocean is venting into space, making it possible to study without drilling through ice. Saturn's rings and moons are connected. Ring particles interact with nearby moons. Some moons form within the rings. Others shape the rings through gravitational influence. Shepherd moons maintain ring boundaries. They keep particles confined, preventing them from dispersing. Over time, the rings themselves may evolve. They may be remnants of a destroyed moon, or material that never formed into one. Their origin is still debated, but one thing is clear. Saturn is not a single object. It is a system, a dynamic structure where gravity, motion, and time interact. Understanding Saturn means understanding how systems form and evolve. Not just planets, but entire environments,